Hello, my champions. How are you all? Good evening, Sanjana. Good evening. Hello, everyone. So, I hope yesterday's hangover is over, right? We had a very fun time yesterday. Those who attended the lecture, right? Good evening, Shobha. Good evening, Sanjana, Nitesh, Rajesh, Usha, D-Boss, Shaukan, Manikant, Super Secret. Hello everyone. Hello Amaya. Okay, so today again, so we will be doing a quick revision again, all the topics as quickly as possible. And I don't want to waste any time like yesterday, so we will be doing some important MCQs, some fill in the blanks, and then some 2-3 marker and some numericals as well as some derivations. Now derivations, if you I will give you the option that which derivation you want. Okay, just a second, sorry, maybe my voice is not clear. Hello, yes, yes, can you hear me now? Yes, everything I will cover. Iconic, all fixed marks, 5 marker, 2-3 marker, and some practice MCQs. I don't say that these MCQs will come, but obviously after doing 200 MCQs yesterday, you should be able to answer these MCQs. These are different MCQs. So let's see. SI unit of surface charge density is. What is the SI unit of surface charge? Live, Lucas, live. We are not doing many recorded videos. This Iconic, if you watch this video, you will be at least score 40 marks, okay? At least 40 marks. 2-3 marker, 5 marker, and numericals. Everything we will do. SI unit of surface charge density is surface charge density. Bunny is saying B. Yes, of surface charge density is charge divided by surface area. So Coulomb by meter square. Okay, Coulomb by meter square or Coulomb meter to the power -2 is the answer. Next, the values of electric field E and electric potential V at any point on the equatorial plane of an electric dipole are such that. So values of electric field and electric potential at a point on the equatorial plane of an electric dipole such that E equals to 0, V equals to 0, E equals to 0, V not equals to 0, E not equals to 0, V equals to 0, E not equals to 0, V not equals to 0. So Iconic, just let me do the MCQs first, okay, quickly. Srushti is answering C. Hi Tejashwini. Yes, I will upload the PDF once the lecture is over. Distortion is saying 2C. Yes. So on the equatorial plane of a dipole plus Q minus Q, on this axis, remember that potential is 0. Potential is 0. Electric field is not 0. We have actually calculated what are the electric field, right? So electric field is not 0, but potential is 0 because positive, negative, potential will be add and cancel. Next question. If the potential difference across a capacitor is doubled, then the energy stored in it. Potential difference across a capacitor is doubled, then energy stored. Energy stored is given by half CV square. Now C is constant, so if you double the voltage, energy will be quadrupled or 4 times. Okay. Yes. Shoaib Khan, yes, 5 marks I will do. Just answer the MCQs. MCQs are important as well. Do not ignore them. MCQs is the area where you lose marks. I will do the 5 marker first. Okay, after this MCQs are done, I will start with 5 marker first. Okay, identify the wrong statement from the following. The drift speed acquired by free electron per unit electric field is called mobility. The conductivity of semiconductors decreases with increase in temperature. So you have to identify the wrong statement. So this is the wrong statement. Conductivity of semiconductors increases with increase in temperature. Okay, drift speed by electric field is mobility, correct statement. Conductivity of conductors decrease with increase in temperature, yes, correct statement. Alloys widely used in the construction of standard resistors because their conductivity is constant. Okay, yes, correct. 1B, no, 4B. It is question number 4. Next question, a charged particle of charge small q is moving in a uniform magnetic field. The angle between the velocity v of the charged particle and magnetic field b is theta. The trajectory of the charged particle varies with angle theta. Match the following table by choosing the appropriate trajectory traced by the charged particle. So theta equals to 0, 90, 45. So as I mentioned yesterday, 0 means straight line, 45 means helix, and 90 degrees circle. 0 is straight line, 90 degrees circle. Any other angle other than 0 and 90 will be helix. It is not only 45 degree, even if it is 30 degree or 60 degrees, it will be helix. Okay, so correct match is B, C, A. B, C, A. Correct match is B, C, A. So option B is correct. Okay, yes, fast, super fast. Below are the two statements related to magnetic flux and magnetic field lines. Statement number 1, the net magnetic flux through any closed surface is 0. The number of magnetic field lines leaving the surface is balanced by the number of field lines entering it. So total magnetic flux through a closed surface is 0 because total number of field lines entering and field lines exiting are equal. So obviously both statements are true and 2 is the correct explanation. 2 is the correct explanation. Next, the polarity of induced EMF in a coil is given by. Polarity of induced EMF is given by this question. Question number 7. Yes, A. Lenz's law. Polarity of induced EMF is given by Lenz's law and magnitude is given by Faraday's law. If the question is asked magnitude is given by Faraday's law, polarity is given by Lenz's law. Next, in a transformer, the windings of the primary and secondary coils are wound one over another. So in a transformer, the primary and secondary, sometimes they are wounding one over another to avoid something: flux leakage, resistance of the windings, eddy currents, hysteresis. Which is the reason, which is the loss that we want to avoid by designing it such a way? Yes, so flux leakage is the answer. Most of you have answered correctly. Not 8C, not is 8C distortion. Okay, eddy current is laminated core. Lamination happens, eddy current. Okay, winding one over another is flux leakage. As resistance of the windings, you can use copper wire having low resistance, and hysteresis is soft iron. We use soft iron as the core. Okay, so all four losses are important. Flux leakage is winding one over another so that the flux coming out of both of them are linked with each other. Okay, resistance of the winding, copper wire is used. Copper is very low resistance and obviously cheaper. You can use silver, but obviously silver is much costlier, so that's why silver is not used. Copper is used, not aluminium. Aluminium is higher resistance. Eddy current, for eddy current we use laminated core, and hysteresis we use soft iron as core. So these are the four causes and their remedy. Next, the electromagnetic waves suitable for radar system used in aircraft navigation are. Okay, yes, perfect. If you can complete that note, Brahmastra is always much better than this. This is just a revision. Those who want to revise just before exam, then for them, and those who want to just know what are all the important questions that might come in this year. So this is this year specific. Brahmastra is overall. Okay, Brahmastra is something which some not important question for this year also done in Brahmastra. Okay, but yes, that is a almost zero risk. If you study Brahmastra, all questions you will get. Even the question is hard, you can answer from Brahmastra. Okay, I think 20 or 15 MCQs I think. Today I am not doing too many MCQs. Okay, the electromagnetic system, what is the answer? It is not infrared, it is microwave. Microwave is actually the answer. Yesterday microwave option was not there. That's why I answered infrared. Okay, now remember, if microwave is given in radar system, microwave is much more preferred way to communicate than infrared. Okay, if microwave is not given, closest one is infrared. Okay, remember, in radar system microwaves are used. If microwave is not given, then infrared you can answer. Next, a ray of light is incident on glass air interface at an angle greater than the critical angle of the pair of the media, then the ray undergoes. Sir, are these from question bank? These are question bank, previous year paper, from multiple sources we have collected it. Okay, we have a question bank. We have a question bank of ourselves. Obviously, we did 214 question yesterday. All the sources from all different sources we have collected, and we kept it from that source. We randomly pick some questions and we give it to you. Okay, so that the questions are not repeated. You should not feel bored, and you should always get a chance to answer new question. Okay. A ray of light is incident on glass air interface at an angle greater than the critical angle for the pair of media, then the ray undergoes. Hello, hi Jia. Badass Brahmastra is there in our channel in the playlist section. In our channel, if you go to the playlist section, you will find Brahmastra Physics. There all the chapters are done one by one. Okay. So partial reflection, partial refraction, total internal reflection. In this case, we observe total internal reflection because angle is greater than critical angle. If it is equal to, then last option will be the answer. Remember this. If it is greater than, it will be total internal reflection. Next, to observe sustained interference pattern on a screen placed at a suitable distance in Young's double slit experiment, which of the following conditions are necessary? Sources of light should be coherent, yes. Sources of light should be narrow, yes. Sources of light should be very close, yes. So both A, B, C, both A, not both, all A, B and C. Okay, three conditions, all three conditions has to be satisfied for sustained interference. Okay. Next, the de Broglie wavelength of a moving particle is independent of dash of the particle. De Broglie wavelength depends on mass. So de Broglie wavelength, if you forget, is given by H by P. P is momentum, that is H by mv. So it depends on mass, it depends on velocity, it depends on momentum. So mass, speed, momentum, all three it depends, but there is no charge over here. So de Broglie wavelength is independent of charge. For an electron revolving around the nucleus, kinetic energy and potential energy are positive, total energy is negative. Kinetic energy is positive, potential energy and total energy are negative. Potential energy is negative, kinetic energy and total energy are positive. Kinetic energy and potential energy are negative, total energy is positive. Answer this quickly. Bunny, 90% you are correct. 90% chance that there will be no derivation from ray optics. Okay, we are also not doing any. If there is a derivation, that will be a 3 markers or 2 marker derivation. F is equal to r by 2. Long form derivation, I am not expecting that will come from this year, at least for this year. Okay. According to the blueprint they have shared, high chance is that numerical will come from ray optics and derivation will come from wave optics. Kinetic energy is positive. Kinetic energy is always positive. Potential energy and total energy are always negative. Potential energy negative means the electron is bound to the nucleus. Okay, and potential energy is much bigger than kinetic energy, so that overall energy is negative as well. Okay, so kinetic energy is positive. Potential energy and total energy are negative. The ratio of nuclear densities of aluminium 27 and copper 64 is. Ratio of nuclear densities. Yes, you can, Shabana. Hi. I will cover all different types of questions. Yes. Venkat Krishna. Option A, yes, ratio of nuclear densities. Don't go for this trap. Okay, nuclear density is constant quantity. Nuclear density is constant for almost all stable nucleus. So that means nuclear density for aluminium and copper will be constant. That is 1:1 is the answer. Now next question. The energy band gap in conductor, insulator and semiconductors are respectively E1, E2 and E3. The relationship between them is, okay, for conductor, insulator and semiconductor. Okay, so this is semiconductor, this is insulator, this is conductor. Conductor is almost 0. So conductor is the smallest band gap. Okay, so this is the smallest. Next is E3, which is semiconductor, and then will be E2, which is insulator. Insulator has highest band gap. Okay, so it will be E1 less than E3 less than E2. So correct answer is option D. Okay, now before I continue, just wanted to tell you that currently our Holi offer is going on our all of our courses. KC30 crash course you can purchase for 2499. Classes will start from 21st of March. Lakshya KCET offline crash course is also available. For that 3,000 rupees off is going on currently. It will be a center based crash course. You have to attend to the center, nearest center. If you are in Bangalore, or if you are outside Bangalore, you have to come to Bangalore and stay in one of our residential facilities and attend the crash course. And ABHYAS KCET test series, it is available all time low price of 999 only, and this is a limited period offer. So if you are really interested for KCET preparation, you can purchase today. Next, fill in the blanks. Mutual induction, inductance, diffraction, magnification, quantization, interference. One of the basic properties of electric charge is quantization. Quantization is basic property of charge. The ratio of magnetic flux linkage to the current in a coil is called mutual induction or inductance. Tell me quickly. Yes, ratio of magnetic flux linkage to the current in a coil. So if there is only one coil, then it will be inductance. If it is multiple coil between two coils, it is called mutual induction. Okay, one single coil is inductance, multiple coil is mutual induction. Okay, the principle of working of a transformer is mutual induction. Okay, so here it will be mutual induction. So this is very tricky. Okay, both can be the answer. Microscope is used to produce a large of dash objects, large image of small object, or large magnification of small object. Okay, here magnification is given. Okay, magnification. So make sure you read the options. Mutual inductance is done, inductance is done. Next is the phenomena of bending of light around the around the edges of an obstacle is called diffraction. It is called diffraction, not interference, but it is called diffraction. Yes, correct. Not interference. Amruta, not interference. Bending of light around a sharp edge is called diffraction. Okay, interference when two or more coherent light meet at a point and give rise to brightness and darkness, that is called interference. And diffraction is only one ray, and one ray is bending around a sharp edge. Next, okay, someone was iconic, and one more student was asking, sir, I want to 5 marker first. So let me go into the 5 marker first. Okay, then we'll come back. Okay, so derive the expression for electric field at a point on the equatorial plane of an electric dipole. I think this is the first. Yes. So this is the first, and my expectation, as I told you multiple times, that I am expecting electric charges this year. Derivation will be coming, but you should also practice point charge, electric potential due to a point charge. I think I have it. I am not sure. Let's see. Derive the expression for electric field at a point on the equatorial plane. So we have a dipole, plus Q, minus Q, and we want to find the electric field on the equatorial plane. Equatorial plane means the line which bisects the dipole into equal halves. So if the total distance of the dipole, say 2L, then this divides the dipole into L and L. Okay, now if you join this point and this point, because this is a this line divides the base into two halves, we can say this is an isosceles triangle. Isosceles triangle means this side is equals to this side, this angle is equal to this angle. Okay, that is the meaning of isosceles triangle. Now if you consider the electric field due to this positive charge, it will be in this direction. If you consider the electric field due to this charge, it will be into this direction. Okay, now what? So if you see that electric fields E plus and E minus both are completely different directions. Okay, so there are two ways to do that. One easiest way is that you take the components, y component will cancel, x components will add up. Another is you find the angle between them, then use vector addition principle, which will be very long. Okay, this will be easier. So if you take the y components will cancel because both of them will have same magnitude, but x component will be added up. So if this is E, then this will be 2E cos theta. What is theta? This angle is theta, then this angle will be theta, this angle will be also be theta. Do write the description of the diagram. You have to write the description of the diagram briefly. Okay, you can write is that the dipole is there as shown in the diagram. If you mention that at least, okay, as shown in the diagram, that sometimes can be considered that you have explained properly. Okay, now you have to start writing with this. So electric field due to the positive charge and negative charge will be same magnitude wise because they are equidistant. Okay, they are equidistant, and that distance is given by square root of r square plus l square. This is from Pythagoras theorem. Okay, so this is r dash, this is l, this is the height r. Okay, now so electric field is given by k q upon r dash whole square. Okay, or k q by r square plus l square, right? If you take the square of this, now the net electric field is only exist along x-axis because y component cancel each other. That also you have to write. Okay, so what is that net electric field? Net electric field will turn out to be 2E cos theta. Okay, therefore net electric field is 2E cos theta. Now you have to put the value of cos theta from this triangle. Okay, from the triangle cos theta can be written as, obviously E value we have calculated, kq by r square plus l square, and cos theta is base by hypotenuse. So base is L, hypotenuse is r dash is nothing but r square plus l square, square root. So net electric field we get as k into q into 2l. These two we have incorporated inside the bracket, and we get here r square plus l square to the power 3 by 2. Okay, it is l square plus r square to the power of 3 by 2. Right? Now this is the net electric field. Now what you have to do, you have to simplify. First of all, what simplification you have to do? K into P divided by r square plus l square to the power of 3 by 2. What is this P? P is Q into 2L, called dipole moment. Dipole moment. Okay. Next, what? Now you have to simplify this. For R very, very greater than L, we can write the net electric field is given by K into P divided by R square to the power 3 by 2, which is equals to Kp by R cube. So we have ignored this L square. Why we have ignored? Because R is very big compared to this L. So this L square will be very tiny compared to R square. So 100 square plus 1 square, suppose. So 100 square is 10,000. 1 square is 1. So 10,001 or 10,000 almost same. So that's why we ignored that 1 square. Okay. So we get here as Kp by r cube, or net electric field is given by 1 by 4 pi epsilon naught P upon r cube. So K value is 1 by 4 pi epsilon naught, or E net vector equals to minus 1 by 4 pi epsilon naught P vector by r cube. Okay, here you have to mention E vector and P vector are in opposite direction. Very, very important to mention it. Okay, so P vector is from negative to positive. Okay, so this is the direction of P. Net electric field is in this direction. So this is electric field net. Okay, so that is why the direction of net electric field and P vector are opposite. That is why there is a negative sign. You cannot skip this negative sign. Clear? Is this live enough for tomorrow, Veda Prakash? If you want to score at least 30-40 marks, yes, sufficient. Define electrostatic potential due to a point charge and arrive at the expression for electric potential at the point due to a point source charge. Now the first one I am not doing. I will explain what is the definition of potential. Definition of potential is the work done required. Sir, please do current electricity derivation. Current electricity derivation also you will do. Just salpa wait mari. Okay. Define the electrostatic potential due to a point charge and arrive at the expression for electric potential at a point due to a point source charge. This derivation is also important. What is the definition of electrostatic potential due to a point charge? Work done to bring a unit positive test charge from infinity to a point in electric field is called the potential of that point. Okay, so we will apply that definition to find the potential at a point, say P. Potential at a point. So this is our source charge, capital Q. We are trying to find potential at this point P. And here we have, let us take 2 points A and B separated by a distance small dx. The total distance from the source charge is x. This distance is r. Okay, now obviously according to the definition we have to start at infinity and bring the test charge from there to here. Okay, so we have started at infinity. We have arrived at this point A. We have arrived at this point A. What will be the electric force acting on the charge? Electric force acting on this charge is given by Q into electric field, which is obviously here Q is unit positive charge. So 1 into KQ by x square. Electric field at this point, KQ by x square. Okay. So here we get electric field is KQ by x square. Now the external force that we have to apply, must be equal but opposite to this force. Okay, external force has to be equal and opposite to that force, so it will be minus KQ by x square. Minus KQ by x square. Okay, so this is the external force. Now what is the work done? Work done required to bring by a small distance dx. Okay, work done required to bring it by a small distance dx is given by the external force that you have applied into distance. Force into distance is work done, first PUC knowledge. Okay, so you will put that minus KQ upon x square into dx. Do not forget this negative sign. Now total work done to bring it from infinity to this point R is called electric potential. Okay, so electric potential is total work done to bring it from infinity to this point. That means it will be minus infinity till R KQ by x square into dx. Okay, now what? Now take this minus sign out. KQ is constant. You get integration infinity till R dx by x square. Okay, so if you do the integration, you get work done. Obviously work done equals to potential. You don't need to write W again. So potential is given by minus KQ integration of 1 upon x square is minus 1 by x and limit is infinity till r. Okay, so minus minus cancels, we get plus kq. First is upper limit 1 by r minus lower limit 1 by infinity. So we get kq upon r. Okay, this is the expression for potential. So potential is given by 1 by 4 pi epsilon naught q upon r. So at the last stage you have to put the value of k. Okay, clear? Easy derivation. Next, derive the expression for effective EMF and effective internal resistance of two cells of different EMFs and internal resistances connected in series. Series is most asked. Parallel came but very rare. Okay, parallel is very rare, series is most important. Two cells, say E1, R1, E2, R2, connected across external resistance capital R. Okay, so this is the circuit given to you. What you have to do? You have to replace these two batteries using only one battery. Okay, that battery is equivalent battery, and we have to find this equivalent EMF and equivalent internal resistance. External resistance will be same. Now what things that remain same? So here the thing that is remain same is the current. Okay, current is constant. In series combination, current is constant. Okay, now what? So first we will apply Kirchhoff's law in this circuit. Kirchhoff's law in this circuit. Now remember, if current I is exiting a battery, same current should come back. Similarly, same current should come back here as well. Okay, so entire circuit will have the same current I. So first we will start with this two resistor, applying Kirchhoff's voltage law in circuit number 1. This is circuit number 1. This is circuit number 2. So applying KVL in circuit number 1, what we get? I into capital R, everything will be positive, equals to E1 plus E2. Remember that if we are going in a direction where the battery is sending the current, on our right hand side potentials will be positive. If we are going in the direction of the current, on our right hand side potentials will be positive and added. What is your question, Krishan Mandya? Is it okay if I practice only current, electricity and alternating current for my numericals? Yes, Dia. Current, electricity numericals are tough, difficult. That's why I generally do not recommend. Krishna, what is your question? I can only see yes, please and lot of emojis. Hey, my Devi, what is your problem? Sir, your 10-hour video is enough to score 65 ESG. You should not try ray optics or current electricity. Both can be difficult at times. Okay, there are tendencies that difficult questions can be asked. If the question is easy, like last year from ray optics and current electricity, you can answer. But if it is a circuit diagram based question like 2024, you may be in trouble. Okay, circuit diagram based questions are really tricky. Even if you make a small mistakes, entire answer will be wrong. You will get 0 marks. Okay, if you are very confident, then spherical shell derivation will ask. Spherical shell, which one? Which one? What is your question, Supriya? Holi is done. Yesterday it was done. Yes, Spandan. I was thinking the same. Okay. Huygens principle of wavefront. Okay, I will do it. After this derivation, I will do it. Shoaib, any one of them can be asked. Okay, series combination of cell parallel combination of cell or Kirchhoff's law. Now out of that, series combination, there is a high chance series combination can be asked, but parallel combination can also be asked. So be prepared if you see parallel combination. Okay. But series combination is most common. Parallel combination did came once or twice, but series combination is most common. Now from here we get IR plus I into R1 plus R2 equals to E1 plus E2. Okay, so IR equals to E1 plus E2 minus I. Stop asking question, start study. Okay, if you start thinking that sir what questions will come, if you think too much, okay, if you think there is a tendency, I know you are panicked, I know you are tensed, but don't panic. Calm your heart. Okay, first of all, we are trying to help you out as much as possible. So calm yourself down. Then say to yourself that okay, whatever I have done and whatever I am doing should help me to score well in tomorrow's exam. If you keep panicking, no, you will not be able to study anything, you will lose on everything. Okay, so it is all or nothing kind of situation. But you should think yourself, okay, I have worked hard so far. Okay, maybe I have slacking in the beginning of the class, in the beginning of the year, but last few months I have done hard work and that should pay off. Okay, if you are someone who has not studied at all, okay, you want to just pass, go check my passing package. That is sufficient for you to score 45 to 50 marks. Okay, and if you are someone who is striving for 60 plus marks, 65, 70 marks, okay, then you should continue. And what we are doing, we are revising the concepts. Revision is very, very important. Always revision is always important. Okay, maybe you are a beginner, maybe you have completed the syllabus. Revising is important. Sometimes you can do it yourself, sometimes you cannot do it yourself. That's why I am here, I am helping you out with the revision. Okay, so understand that. And in between, if you have any general really subject specific doubt, do ask me. General questions try to avoid. Think yourself, okay, whatever I have done, it will pay off, all is well. Okay, just think in your heart, all is well. Okay, so that will be very, very helpful. Calming yourself down is very important. If you keep on thinking what will happen, nothing will happen. You will lose in your exam. So don't think about that, right? So whatever you have studied, that will going to come in your exam, and you have to just write them and you have to revise them. Revising, I am doing it here along with you, right? So applying KVL in circuit number 1, we get this. Applying KVL in circuit number 2, we get IR plus IR equivalent equals to E equivalent, or IR equals to E equivalent minus IR equivalent. So if you see this equation number 1 and equation number 2, you will see that left hand side both cases we have IR, so that means this must be equals to equivalent EMF and this must be equals to equivalent resistance. So comparing equation 1 and 2, we can write that E equivalent equals to E1 plus E2 and R equivalent equals to R1 plus R2. Okay, now let's move on to the next derivation. Arrive at the balanced condition of Wheatstone bridge using Kirchhoff's rules. First of all, the circuit diagram you have to draw. Okay, I am not drawing the diagram today. I have drawn this multiple times. So this is the circuit diagram. Current I1, I2 passing through this. This current is I3, this current is I4. Now what you have to do, you have to find the balanced condition. What is the balanced condition? For balanced condition, the current through the galvanometer, IG, okay, that IG should be equals to 0. That is the balanced condition of Wheatstone bridge. Okay, so IG equals to 0 is the condition for balanced Wheatstone bridge. Okay, now what you have to do, now next part is you have to take these any two of the closed path, and once you take the closed path A B D A and B C D B, what you will be seeing that you have to say that okay, this is a closed loop, this is a closed loop, so I can apply Kirchhoff's voltage laws in both cases, and correspondingly we can find the equations. So A B D A loop A B D A, in the loop what we get, okay, voltage drop across this is resistance into current, so I1P. When you are going from B to D, Ig is 0, so 0 into G, okay, and when we are going from D to A, to close the loop, we are going against the direction of current. Against the direction of current means it will be minus, so minus I2 into R, that is equals to 0. Okay, so we get I1P equals to I2R, or I1 by I2 equals to R by P. Okay, this is my equation number 1. Similarly, from the loop, from loop, what is the loop? B C D B, B C D B. Okay, current is passing through this resistor is Q and current is I3, so I3 Q plus not plus, minus I4 into S, minus I4 into S plus 0 equals to 0. Why on our right hand side everything is 0? Because if you consider this loop or this loop, both cases there is no electric cell. Electric cell is outside the loop. So if the electric cell is outside the loop, we will not consider it. That is Kirchhoff's voltage law. Okay, so from here we can say I3 equals to I3Q equals to I4S, or I3 by I4 equals to S by Q. Okay, now because this Ig is 0, I1 must be equals to I3, so I1 must be equals to I3. Similarly, I2 must be equals to I4 because there is no current passing through this, so I2 must be equals to I4. Now you have to put that in this equation and you get I1 by I2 equal to S by Q. This is my equation number 2. Now if you compare equation 1 and equation 2, you will get R by P equals to S by Q, or do cross multiplication, you get P upon Q equals to R by S. Okay, P by Q equals to R by S. Sir, I am Chandan from 24 batch. Thank you for all your academic support. Hi Chandan, how are you? Long time no see. Hey Rohit, go away. You are not studying here. If you are not a student, go away. Okay. So if you have completed my revision, then you should go and sleep. Okay. You should not be here. Yes, badass, we will do that as well, don't worry. But this is also very important question for this year. Okay, you should practice this derivation. Derive the expression for magnetic field at a point on the axis of a current loop. 90% chance is this will come. Okay, this will come in your tomorrow's exam. So this is the current loop, this is the axis, this is the point where you are trying to find the magnetic field. If you join this, this will be your distance, say R. The radius of the loop is capital R. Remember the diagram. If you solve the diagram itself, 90% problem will be solved. So from Pythagoras theorem, it will be R square plus X square to the power half. Okay, this is R. Now take a small element dl, take a small element dl, the dl will make an angle theta of equals to 90 degrees. This is a three-dimensional diagram. So this is along this is along this, that's why the angle is 90 excuse me, theta equals to angle 90 degrees. This angle is phi, this angle is phi. Do not mistake with this angle and that angle, okay? Yes, Devika, there is a every year one rectifier question comes, okay? In model paper they give one more extra question, but either half wave or full wave comes every year. Yes. Sanjana, model paper is not enough to score good marks, it is enough to pass, okay? Historically, now that record may broke this year, or completely you might get a question which is completely not related to model paper. Historically speaking, last 3-4 years, the trend is if you follow the model paper, you can score 25, 30, around 35 marks, okay, if you take the closest questions into account as well, okay? So if you take the everything into account, then 35 marks maximum comes from model paper. That varies from subject to subject. I can tell you only about physics. From physics, maximum up to 35 marks came in last few years. Last year and this year they are giving 3 model papers, including considering everything. All the model papers considering last year also, it was only about 30 marks, not more than that, okay? So you should not rely too much on model paper. Again, you should not ignore the model paper as well, okay? Now, so this is the configuration. Now remember that the magnetic field for this will be another plane, okay, and that magnetic field will make an angle phi with this axis, okay? Now what we have to do, we have to find the magnetic field, the small magnetic field due to small element dl, and that will be given by Biot-Savart's law. So you have to mention from Biot-Savart's law, mu naught by 4 pi, okay, I dl divided by r square. Sir, you made a mistake. Where is the sine theta? Sine theta is 90 degrees, so sine theta is 1, okay? Now if you see that here, this is a circular coil. Circular coil means it is a symmetric surface. So due to symmetry, if you take a y component of this vector dB, what you will get? Due to this point, if you consider this point, you will get y component along this. If you take this point, you will get an y component along this. So y components will cancel each other. Only the x component will be left. So only dBx we need to consider. Y components will be cancelled. So due to symmetry, y component will cancel, only the x component will be there. So dBx equals to dB cos phi, okay, y cos phi, because this is the adjacent angle, this is the adjacent side, so this angle will this component will be cos component. Now how to find cos phi? To find cos phi, you have to go back to this triangle. In this triangle, you see this is the angle phi, this is the base, this is the perpendicular, and this is hypotenuse, okay? So from there we can say that it will be dB r by small r, okay, r by small r. Now dB, you have to write the value of dB, mu naught by 4 pi I dl r square into r by small r, okay, 4 pi I r dl by r cube, okay. Rohit, if you are not stopping, I will put you into timeout, okay? Final warning. Atoms and nuclei you can skip. 2-3 marker questions will come from that chapter. Few 2-3 marker questions you should practice from there. Easy question. Okay, drawbacks of Bohr's model. Okay, postulates of Bohr's model. Similarly, features of nuclear forces. Okay, but yes, you have to compulsorily attempt the MCQ questions from those 2 chapters. So even if you avoid these 2 chapters, I recommend you should read the NCERT summary of these 2 chapters. Okay, at least go through the NCERT summary of these 2 chapters. That will be very, very helpful. Sir, will we get similar numerical from model paper, like only the values change? No, not at all. Numerical questions will be completely new. Okay, if you understand the concepts, you will be able to answer. Okay, model paper questions, obviously you have to practice, understand what approach you are making, how you are calculating electric field, what formulas you are using, and if the value are changed, some other in other context, if the same, how to apply the same formulas. So you have to understand the concept in depth so that you will be able to answer the numerical question. Numerical questions generally do not come from model paper or in previous year papers. Yes, it do come from your NCERT with the values change, with some context changed. Okay, some additional portions added to the NCERT paper. Yes, that did happen in the past, but not from model paper. Okay. Numalandar, we have already completed the MCQs for today's session. Yesterday I did a long marathon of 200 plus MCQs. Do check that out if you are really worried about MCQs. You can currently it is available. You can check it in 2x speed if you are interested. Okay, PDF is already available in our WhatsApp channel, so don't forget to join the WhatsApp channel. If you have not joined yet, the links are already shared there. The files are already uploaded in the drive, so do check that out. 2 more question coming. PN junction is asked frequently, not so frequently. PN junction is not so asked frequently. Only forward biased have been asked once or twice. Otherwise, from PN junction, a diode, obviously rectifier is being asked. What is rectifier? That is all. Every year it comes. Sometimes it be asked that band theory, okay, in terms of band theory, differentiate between conductors and insulators. In terms of band theory, differentiate between conductors and semiconductors. You have to mention the band gap. Okay, what happens when electrons? How electron moves inside a conductor? How electron moves inside a semiconductor? And intrinsic and extrinsic. That is the most asked question. Difference between intrinsic and extrinsic. What is intrinsic? What is extrinsic? So those questions are more common than PN junction. PN junction only forward biasing came 1 or 2 times. Okay. Now mu naught by 4 pi I r dl by r cube. So this is dBx. Okay, and it is mu naught by 4 pi I r dl by r cube. Okay. Now what you have to do? You have to mu naught by 4 pi I r divided by r cube dl. Okay, this everything is constant, only thing that is changing is this dl. So when you try to find the total magnetic field, bx, it will be integration of dbx, obviously close integration. Now in this, obviously this everything is constant, mu naught by 4 pi I r by r cube into integration of dl. Now integration of dl means, obviously if you take the integration, you will get the circumference of the circle. So that will be mu naught by 4 pi I r by r cube into 2 pi capital R. Circumference of a circle is 2 pi capital R. So 4 pi, 2 pi cancels, you get a 2 over here, and the remaining, now let us finish the answer. Mu naught by 2 I r square divided by r cube. R is r square plus x square to the power of half, and cube of that means it will be r square plus x square to the power 3 by 2. In the bracket you write r equals to r square plus x square to the power of half. So this is the expression for magnetic field on the axis of a circular coil. Very, very, very important. Okay, if you have not practiced, do practice this. This is going to come in your exam. Next, what is half-wave rectifier? Okay, explain the working of a half-wave rectifier using neat circuit diagram. Also draw the input-output waveforms corresponding to it. A half-wave rectifier is the electric circuit that converts alternating current AC into direct current DC by allowing current to flow only during open one half cycle of the AC input signal. The other half cycle is blocked, so only half of the AC wave is used. Okay, now here remember that circuit diagram, half-wave rectifier, only one diode is there. Okay, and when you are drawing the input output waveform, this is the input waveform, this is the output waveform. Okay, and you have to match the input output waveform like this. Okay, during the positive half cycle of the AC input, the P side of the diode is positive with respect to the N side. The diode becomes forward biased and conducts current. Current flows through the load resistor RL in one direction and voltage across the load is positive. Okay, during the negative half cycle, so here you have to separate the positive and negative half cycle for half wave as well as in full wave. During negative half cycle of the AC input, the P side of the diode becomes negative with respect to the N side. The diode is reverse biased and does not conduct. No current flows through the load resistor RL and the output voltage is 0 during this half cycle. Okay, now again full wave rectifier, the most important question, the gem of the question. It is coming repeatedly year after year. Half wave did came twice, but full wave rectifier is coming almost every year. Okay, and those who are writing multiple papers, means March paper, April paper, June paper, they also getting this paper, question repeatedly. Okay, so do practice this as well. A rectifier is an electric device that converts alternating current AC into direct current DC. Positive half cycle of AC input. During the positive half cycle of the AC input voltage, the upper half of the transformer secondary winding becomes positive. Diode D1 becomes forward biased and conducts allowing the current to pass through the resistor RL in one direction. And diode D2 remains reversed bias and does not conduct. The diagram is very, very, very important. Here we have two diodes. Okay, one diode is connected. Both diodes, if you see, are connected across, like this is the transformer. So both end have one diode, and we have a center tap from where the output is being collected. Okay, this is very, very interesting. Okay, this is very, very interesting circuit diagram. Circuit diagram you should practice and remember it. Okay, next is negative half cycle of the AC input. During the negative half cycle of the AC input voltage, lower half of the transformer secondary winding becomes positive. Diode D2 becomes forward biased and conducts, while the diode D1 is reverse biased and does not conduct. Now during this, only one input diagram is sufficient. Okay, this is the input diagram, and if you take the output, but you have to mention that due to D1, this graph you are getting due to D1, and this graph you are getting due to D2. This must be mentioned in the input output waveform graph. Okay, and everything should be linked like this. Okay, current again flows through the load resistor RL in the same direction as during the positive half cycle. Okay, so these are all the important, very important 5-marker question. You should not skip any of them in this portion, obviously. Okay, now let's move on to the 2-3 marker questions. Okay, all 2-3 marker questions are also very, 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 very important. Okay, what is your question, Sania? If you study model paper, how many marks? Sania, by this time, no, what I think you should have completed model paper 5 times. If you are coming here and asking this question, means you have not studied anything. So if you study model paper, you can score 30 to 35 marks, not more than that. Okay, so instead of asking model paper, you should have completed model paper, you should have completed 1-2 more previous year papers, then you could have said, okay, I could score 50 marks, right? This is not enough, but this is the last minute revision, okay, last minute suggestion. And if you are lucky, you will get all three derivations. If you are not slightly unlucky, then maybe they might change one of them, one of the derivations, but you should get two derivations if you practice all of them. Two derivations pakka, one derivation slightly luck. Okay, two derivation is fixed. So all the derivations that I did today, if you do all of them, two derivation is guaranteed, one derivation is slightly on luck. But tomorrow also morning I will be coming back with the live session. There I will do more derivations, some more last moment derivation practice. I will mostly it will be just a last minute revision kind of strategy, so that you can just want to revise. Don't you are not willing to study from your textbook, just want to stay here, focus and prepare for some time. 1 hour live lecture, 6 AM to 7 AM. Do attend that. That session also we will be doing some extra derivations as well. Okay, this class MCQs are important, okay, but MCQs we have done extensive 200 plus MCQs yesterday. That is for exact MCQ preparation. Okay, this is just practice. This is just practice to check whether you are able to answer them or not. So now let's move on to 2-3 marker. State and explain Gauss's law in electrostatic. Gauss's law in electrostatics is one of the most asked question. Every year it is asked either as a 2-3 marker or with the 5 marker question. Okay, it may be coming as an individual question, it may be as asked as a part question of 5 marker question. Both is possible. So Gauss's law states that total electric flux passing through a closed surface is equal to 1 by epsilon naught times the net charge enclosed by the closed surface. Explanation: phi equals to q by epsilon naught and E dot ds equals to q by epsilon naught. Q is the total charge enclosed by the surface. If you draw, if this is an asked as an individual surface, individual question, draw this diagram as well. Okay, draw this diagram, that will be sufficient. Hello Pritam, namaskara, how are you? Okay, now let's continue. This is also super important, super duper important. Okay, write Coulomb's law in vector form, explain the terms, state and explain Coulomb's law. Both is possible. If you prepare one answer, both questions answer can be answered from this single question. Okay, so Coulomb's law states that the electrostatic force between 2 point charges is directly proportional to the product of the magnitude of the two charges and inversely proportional to the square of the distance between them. Coulomb's law in vector form is F21 vector equals to 1 by 4 pi epsilon naught q1 q2 by r square r cap 21. Okay, now if it is only Coulomb's law, vector notation is not necessarily required, but if you are writing it, you have to explain the terms as well. So F21 is the force acting on second charge due to first charge, so that is given by this F21. Okay, q1 and q2 are the charges. Epsilon naught is the permittivity of free space, r is the distance between these two charges, and r21 cap is the unit vector pointing from q1 to q2. Now remember that if the question is asked vector form of Coulomb's law, the diagram is compulsory. Without the diagram, some invigilator, some paper checker may not give you at all any marks. So make sure you have a look at this diagram and practice the diagram. Okay, now let's move on. Write any 3 properties of electric charge. So additivity of charges, charges are additive in nature. Quantization of charges, all charges are integer multiple of smallest charge E. Conservation of charges, total charge of an isolated system is conserved. Yes, Devika, Daivikda. If you study all the questions from question bank, but right now you do not have the time to prepare the question bank, right? If you have completed, very good. If you have, you are still thinking that okay, whether should I study from question bank, it will generally the question bank given to you know, it is you require at least 6 months complete 6 months from the time the question bank was released till today. Okay, you have to study the question bank to finish it completely. You will not be able to finish it in just 1 hour or 2 hours. That is impossible. Okay, so if you are still thinking that I will score if I study from question bank, you will not going to do that. Do one thing, go watch my passing package. You will score 45-50 marks. Okay, do not rely too much on model paper, do not rely on question bank. Right now this is not the time. Okay, if you really want to pass, check my passing package. You will do well in the exam. One video 2 hour sufficient. Okay, you don't need to think, okay, if I study model question, model paper question also 3 papers are there. 3 paper means 35 questions. Okay, my passing package has only around 60 questions. You don't need to study all those. Check my passing package, that is sufficient for you to score 50 plus marks. 45 to 50 plus marks is sufficient. Okay, check that. Netflix 200 MCQ PDF is already uploaded. Yesterday only, after finishing the lecture, I uploaded the PDF, then I went home. Okay, as I reached home at 2:30 am. So those who did not know, we did a very long live yesterday, which I was planning to complete by 12, but it extended by 1.5 hours. It got completed by 1:30. I uploaded the PDF immediately. If you are not part of our WhatsApp channel, go there, check on the link, and you will find the PDF there. Okay, and do not request for permission. You can download it, you can save it in your own drive. You do not require permission in our drive. You can copy it yourself, you can download it yourself. Okay, do that, keep it on your PC. Do not ask permission from our side. Okay, some of you are asking permission from different folders. You first of all, you understand that you don't require any permission. You just need to download it on your device. Downloaded permission is already given to everyone. Next, write 3 properties of electric field lines. Electric field lines may start from positive charge and end at a negative charge. 2 electric field lines are never intersect each other. Electrostatic field lines do not form any closed loop. So these are the 3 properties of electric field lines. Very important question. Write 2 properties of equipotential surface. No work is done in moving a test charge over an equipotential surface. Electric field is always normal to the equipotential surface at every point. No 2 equipotential surfaces can intersect each other. Okay, so these are the properties of equipotential surface as well. Let's move on. Derive the relationship between electric field and electric potential due to a point charge. Sometimes this can be asked, derive that E is equal to minus dV by dx. In 24, this question was asked like this way. So this can also be asked, E equals to minus dV by dx. Same question, relationship between electric field and potential, or E is equal to minus dV by dx. So don't be surprised if you see this question. Okay, now here we have 2 equipotentials, 1 and 2. Okay, so these 2 equipotentials are parallel to each other. Distance between them, let me not use this and this. Let me change the notation. So this will be dx, this will be dv. Okay, here we have 2 equipotentials, one equipotential at the point A, another at point P. Okay, if you join these 2 points, electric field always points from higher potential to lower potential. That is why this is V minus delta V or dV. Okay, now if you take a small charge Q, and try to move it from A to P, then what is the work done? So we will try to calculate the work done in 2 different ways, and then we will compare. Okay, so work done to move the charge from A to P is given by the force acting on this into the displacement. Now what is the force acting on it? Force acting on it is basically the charge times electric field. Charge times electric field is the force, and that is the work done. Now when the charge is moving from A to P, in terms of electric field, what is the work done? Work done is given by Q into change in potential. Change in potential means final potential minus initial potential. So V cancels and you get minus Q dV. Now because both of them are work done, no matter what method you use, work done should be equal in all methods. So we must say that this must be equals to this. So work done will be same in all the method that you use. So Q into E into dx must be equals to minus Q into dV. Q cancels, so electric field turns out to be minus dV by dx. Okay, clear? Neeraj, tomorrow morning there will be a very short quick revision for those just want to score 20-21 marks. That will be 30 minutes, 4 AM, and there will be a live class tomorrow morning 6 AM. That I will be there. Both lectures will be done by me only. One is recorded, one is live. Recorded lecture will go live at 4 AM so that you can still just before exam you are thinking I was not planning to give exam, but I am giving the exam. I want to pass. That 30 minutes may be just sufficient for you to score 21 marks, but yes, all the important questions are being discussed there, and 1 hour live revision with me in the morning. Okay, 6 to 7. That will be strictly 6 to 7. I will not try to extend that beyond 7. Next, define drift velocity and mobility of free electrons in conductors, or define mobility, mention its SI unit. Okay. Competitor, what is your question, sir? Yes. Is it kept in external electric field? Yes, it is kept in external electric field and the work done by the electric field itself, and we are comparing the work done by the electric field itself. We are not comparing any work done by ourselves, because this work done is by the work done by the electric field itself. Okay, that is why we are comparing the work done by electric field itself by while moving the charge from A to P. Okay, remember that electric potential always electric field always points from higher potential to lower potential. So if this is V, this is V minus dV. In your textbook they have done they have mixed internal and external work done, which is completely chaotic, which I do not recommend. The easiest way is to take the actual way it is. Okay, electric field is always pointing from higher to lower potential, and you are calculating using the work done by the field itself. Yes, diagram is compulsory, not important. Diagram is compulsory. Without the diagram, you will get 1 mark out of 3. You will get 1 mark out of 3. 2 mark is there in the diagram. Some teachers might give you 0 as well. Okay, because if you see the instruction from the board while checking the paper, always draw suitable diagram. Without suitable diagram, you will not be awarded any marks. Okay, so make sure that if diagram is there, if it is required, for example here the diagram is required, without the diagram you will not be able to do this derivation. So that's why without the diagram you may not get any marks if the diagram is there. So drift velocity and mobility of free electrons. Drift velocity, the average velocity with which the free electrons drift under the influence of an electric field, is called drift velocity. Mobility, the mobility of free electrons is defined as the drift velocity of electron per unit electric field. SI unit of mobility is meter per second per voltage, or you can say that meter per second Newton per Newton into Coulomb. Okay, so this is also 2 units. How to remember mobility? Mobility is drift velocity by electric field. Drift velocity is meter per second and electric field is Newton per Coulomb. So meter second inverse per Coulomb per Newton into Coulomb. Okay, this is how you can remember the unit. If you don't know how to write this, you can leave your answer here also, you will get full marks. Next, mention 2 limitations of Ohm's law. This question again repeatedly coming year after year. Last year 24, 25, 23, every year this question came. Ohm's law is applicable only if all the physical condition remains same. Ohm's law is not applicable at very high and very low temperature. Ohm's law is not applicable to non-ohmic devices like semiconductors, discharge tubes, etc. Yes, badass. Name the two factors on which the resistivity of the wire depends. Material of the wire, temperature of the wire. This is resistivity, not resistance. Don't make a mistake. One trick just for you, that resistivity is also called specific resistance. So if you see resistance, don't write rho L by A. Okay, resistance is rho L by A, normal resistance. Okay, so resistance depends on length, inversely on area, but this is resistivity. Okay, resistivity or specific resistance, same thing. Okay, I never came in your board, but if they give you this term, CBSE exam, this question was asked multiple times. Specific resistance is same as resistivity. Next, write the expression for magnetic force per unit length between two long straight parallel conductors carrying current. Give the nature of the force between two parallel conductors carrying current in the same direction. Okay, this derivation came last year, so there is a very less chance this derivation will come, but this can be asked in a 3-marker or 2-marker format. Okay, so force per unit length between two parallel wire carrying current is given by mu naught by 2 pi Ia IB by D. Ia and IB are the current through the wires, D is the distance between the wires. Parallel current attract, anti-parallel currents repel. Now here if you add this, in this question diagram is not necessary, but if you can add a diagram, that will give you an edge, saying to the teacher, see teacher, I have came prepared. Okay, I know my questions, I know the answers, I am here fighting for 70. So teacher will consider that. Okay, so this diagram is not compulsory, but if you draw, if you can, you should draw. Next, what is Lorentz force? Write the expression and explain the terms. Force acting on a moving charge particle in the presence of the electric and magnetic field is called Lorentz force. F equals to Q into E plus Q into V cross B. Okay, Q is called charge, E is electric field, V is velocity of the particle, B is magnetic field. Next, how can a galvanometer be converted into voltmeter? One of the conversion is going to come, almost every year it came. Okay, how can a galvanometer be converted into voltmeter? An ideal voltmeter should have infinite resistance in parallel voltmeter, in practical voltmeter, thus resistance is kept as high as possible. To convert a galvanometer into a voltmeter, we need to connect a high value resistance in series to the galvanometer, that is V equals to Ig into G plus R. So this is the diagram, circuit diagram is compulsory here. This equation is compulsory here. What is this V? This is the measurement value. Voltmeter means it measures voltage. So this is the voltage that you measuring. V equals to Ig into G plus R. Next, how can a galvanometer be converted into an ammeter? Explain with the diagram. So ideal ammeter should have zero resistance. In practical ammeters, the resistance is kept as low as possible. To convert a galvanometer into an ammeter, we need to connect a shunt, or shunt means small value resistance. Okay, we need to connect a small value resistance, also known as shunt, in parallel to the galvanometer, and this diagram is again compulsory. Galvanometer, in parallel one resistance is there, the current coming in is I, current going into the galvanometer is Ig, and I minus Ig passing through the shunt. Memorize these diagrams in your head. Okay, I equals to Ig into G plus S by S. Next, derive the expression for motional EMF induced in a straight conductor moving perpendicular to uniform magnetic field. Now this is a derivation you can skip if you want. It came last year, but in PU exam there is no guarantee if it came last year it will not come this year. So you should practice if you get time. So here is a railroad. Okay, railroad, one rail side is blocked, this wire is coming to this side, okay, with the velocity V, and the instantaneous distance at some time is x, the length of this is given by L. Okay, now how to find this induced EMF? To find induced EMF, we must calculate minus d phi by dt. According to combination of Lenz's law and Faraday's law, induced EMF is given by minus d phi by dt. Okay, what is phi? Phi is given by magnetic field into area. Okay, phi is magnetic field into area. The magnetic field is into the page of the paper, so obviously here sin theta cos theta is cos theta is 0 degree. Okay, planes vector and the magnetic field vector, they are both in the same direction, so theta is 0, so it will be only b into a. Now what is b is given obviously in the question. Now what is area? Area of a rectangle. Area of a rectangle is length into breadth, so that is L into x. Okay, so it will be B L x. So induced EMF will be minus ddt of BL x. Now B is constant, L is constant, x is not constant, so minus BL dx dt. Now what is dx dt? So dx is the rate of change of distance, and if you see that as the this rod approaching this side, value of x is decreasing with time. So that means first of all, rate of change of distance is given by velocity. So dx dt is velocity, and as the x is decreasing with time, so dx dt will give you negative of velocity. Okay, so from here we can say that the induced EMF is given by minus b into L into minus v, that is BL v. This is the induced EMF and this is called motional EMF. Sir, wave optics and ray optics, which chapter theory question most important? Wave optics chapters theory questions are most important. Okay, from wave optics, reflection or refraction based question, Huygens principle based question is most likely to come. Or there is one in your model paper also, there is one question in two separate waves superimposing on one point, that derivation might also be coming. Okay, one of the derivation is going to come, and is at least according to my understanding. Describe an experiment to demonstrate the phenomenon of electromagnetic induction using bar magnet and coil. This question also, even though the very simple easy question, it came multiple times. Okay, so here diagram is compulsory because it's an experimental demonstration. Here you have a coil. Okay, the magnet is going into the coil, and there is a galvanometer which is being deflected. Okay, when the magnet approaches the coil, so first what you have to do, you have to draw this diagram, then you have to explain what happens when the magnet coming towards the coil and when the magnet is going away from the coil. So both cases you have to explain, magnet coming towards, magnet going away. When the magnet approaches the coil, the galvanometer needle deflects, indicating a current is induced. When the magnet is pulled away, the needle deflects in the opposite direction, showing that the current reverses. No current is induced when the magnet is stationary related to the coil. Conclusion is very, very important to write in this case. The experiment demonstrates the electromagnetic induction, a current induced in the coil when the magnetic flux through the coil changes. This confirms Faraday's law. Okay, this confirms Faraday's law of induction, and the direction of the current follows the Lenz's law, opposing the change in the magnetic flux. Okay, now let's move on to the next part. This is another important question. Okay, this is a multiple question in one simple table. Okay, what are all the questions possible from here? First of all, this derivation, this difference table can be asked. What is your question, guys? Guys, stop chatting. Tomorrow is your exam. If you are not from second PU, go discuss in another chat, not here. Okay, write the three differences between diamagnetic, paramagnetic and ferromagnetic material. So what is the ferromagnetic? So basically what type of question you can expect here? First of all, diamagnetic, difference between diamagnetic, paramagnetic, difference between diamagnetic, ferromagnetic, difference between paramagnetic, ferromagnetic. Sometimes they might ask you 3 properties of diamagnetic substance, 3 properties of paramagnetic substance, 3 properties of ferromagnetic substance. That is also possible. So this question actually 1, 2, 3 plus 3, 6 question in one single page. Okay. Magnetic behavior, these are weakly repelled by a magnetic field, these are weakly attracted by magnetic field, these are strongly attracted by magnetic field. Magnetic susceptibility, have a small negative susceptibility, have a small positive magnetic susceptibility, have a large positive magnetic susceptibility. Okay, effect in magnetic field, induces a magnetic moment in the opposite direction of the applied field, induces a magnetic moment in the same direction of the applied field, induces a strong magnetic moment in the same direction of the applied field. Okay, next, define magnetization of a sample, how it is related to magnetic intensity. Magnetization of a sample is measure of the net magnetic moment per unit volume of the material. Okay, m is net magnetic moment and divided by volume. So net magnetic moment per volume is called magnetization. Relation to magnetic intensity H, m equals to chi H, where chi is called magnetic susceptibility. Okay. Sir, for 5 mark derivation we should write how much? So for 5 mark derivation, diagram. Okay, diagram, explain the diagram. If you are using any variable, try to explain the variable. Okay, like say you are writing electric field E is given by. So what you have done, you have written that electric field is E. Also you are writing the expression for electric field. So this is a neat trick that used by the topper. When you are writing it, you mention the variables in the bracket itself. Okay, that will save you a time. So after that you have to write electric field is E, R is distance. Okay, so you don't need to do that. You just, while explaining the diagram, that a charge Q is located at point A, we are trying to find electric field at the point B, point P at a distance R. Okay, so that will basically summarize your diagram and also declare the variables. So that is must. Then you can apply from Coulomb's law, from this law. Okay, or from these two vectors are will cancel each other. So that portions you have to explain. Whatever you are doing the steps, try to write that steps in words. That's it. Okay, whatever is happening in your head, you write it. Why you are doing it, write that in the while doing it. Okay, you do not need to write too much long paragraphs. At least point wise describe the diagram. E is the point charge, P is the point where we are finding the electric field, R is the distance, E is electric field. Then, okay, so this much is sufficient. Sir, question 30 derivation for 3 marks, right? Question 30 is which one? Yes, this is a 3 mark derivation. So again, diagram, explain the diagram briefly, that there is a rod PQ moving in the direction V as shown in the diagram. So that is also a way of explaining that whatever you are trying to say is actually you are showing in the diagram. Okay, as shown in the diagram saves you a lot of time. You don't need to explain each and every point of the diagram, because you have mentioned that, sir, please see my diagram. Everything is there in my diagram. Okay, so that is also one important point of drawing a neat and clean diagram. Define magnetization of a sample, how it is related to magnetic intensity. So I have explained it. Next, state and explain Gauss's law in magnetism. Sometimes this can also be asked. Gauss's law for magnetism is the net magnetic flux through any closed surface is 0. So B dot ds equals to 0. Physical significance is that magnetic monopoles do not exist. That is, magnetic field lines always form closed loop. So this is the Gauss's law and its explanation. Mention 2-3 uses of applications of Polaroids. So either it can be asked uses, applications, everything is same. Polaroids are used to control the intensity in sunglasses, window paints. Polaroids are also used in photographic cameras and 3D movie cameras. They are used in 3D movie glasses as well. Give the Cartesian sign convention used to measure distances and heights in spherical mirrors. So object on the left, and remember that you have to mention that all distances along the positive x-axis is positive, all the distances measured along negative x-axis are negative, all the distances measured along the positive y-axis is positive, all the distances measured along the negative y-axis is negative. Okay, these lines you can skip. Okay, this line you can skip, but diagram you have to show. Okay, this is the object, this is incident light, this is your mirror. Okay, this is positive x-axis. You can also show that this is negative x-axis. Okay, this is positive y-axis, and this is negative y-axis. Okay, now let's move on. Write two conditions of total internal reflection of light and mention its one technological application. Light must travel from denser to rarer medium. The angle of incidence must be greater than critical angle between the medium. Application: optical fibers are cables used to transfer data using total internal reflection. Okay. Give Einstein's explanation of photoelectric effect and write Einstein's photoelectric equation. Einstein suggested that each photon of light has energy proportional to its frequency nu, given by E equals to h nu, where h is Planck's constant. When light shines on a metal surface, photons transfer their energy to electrons in the metal. Any energy from the photon exceeding the work function becomes the kinetic energy of the ejected electron. Okay, so this is the observation of numericals. I am doing Sanjana. I have already done the derivations. Derivations is already done. Which one, Neeraj? Draw a ray diagram of an astronomical telescope in the normal adjustment. Write the expression. See, if this comes, you should skip it. There is no point of drawing an astronomical telescope diagram. That is hugely complicated. My simple microscope, astronomical telescope, in your model paper simple microscope is there. Okay, now in the exam, if astronomical microscope is coming, the diagram is very complicated. Even if you make small mistakes while drawing it, you will not get full marks. Those questions are not super convenient for out score or even a good score. Okay, so you should skip and avoid those questions. Generally it never came, historically it never came. One ray diagram was first given in your model paper. Previously there was no ray diagram was asked in the model paper. Okay, microscope was asked first time in the model paper, but in my opinion you should avoid those questions. Okay, yes, quickly. How can a semiconductor diode, I will finish it in another 20-25 minutes. How can a semiconductor diode be forward biased? What happens to the width of the depletion region when forward bias voltage is increased? Semiconductor diode is forward biased when you connect the positive terminal of the power source like battery to the p-type side of the diode and the negative terminal of the n side of the battery. This setup helps to overcome the potential barrier created by the depletion region and allows the current to flow through the diode. As you increase the forward bias voltage, the depletion region becomes narrow and slowly disappears. Someone was asking PN junction based question. This is one of the most common PN junction based question. Now we are solving some numericals, very typical numerical which is very commonly being asked. See first question. Three charges equal to 4 nanocoulomb are placed at the three corners of a square of side 2 centimeter. Find the electric field in the fourth corner. Now whenever this kind of questions are being asked, you have to draw the diagram. Without diagram you will not get any marks. So here we have a square. Okay, 4 nanocoulomb, 4 nanocoulomb, 4 nanocoulomb, and you are trying to find the electric field at this corner. Okay, all the distances are same, 2, 2, 2. Now I made one mistake in one of my similar question. I solved one more similar question in my previous live. where I solving that I took this direction wrong. Okay, so if this is 2, this is 2, this is 2, then this distance will be 2 root 2. Okay, this will be 2 root 2. This is a diagonal. So remember that diagonal for a square is any side into root 2. Okay, now field due to this plus will be in this direction, field due to this plus will be in this direction. So and field due to this plus will be along the diagonal. So all three are in different directions. How to solve that? So to solve that, what we have to do, first of all, we have to find the electric field due to these two charges. Their resultant will be along the diagonal. So finally we have to add all three like this. So first stage, calculate the electric field due to this and this. Now both are having same value and same distance. That means these two magnitude wise will also be same. So what is magnitude of any one of the forces? Magnitude of any one of the forces. Now how to write during the exam? You make them, you give them names. Okay, you give them names A, B, C, okay, D. So this will be not B, this will be C. Okay, EA and EC are EA and EC are same. Okay, this is EA, this is EC. So in the first line you write EA equals to EC equals to 1 by 4 pi. They are magnitude wise same, direction wise they are not same. That is the main issue. Okay, 1 by 4 pi epsilon naught Q upon R square, that is the formula. So it will be 9 into 10 to the power of 9, that is the value of 1 by 4 pi epsilon naught into Q. Q is 4 nanocoulomb divided by R square. R is 2 centimeter. 2 centimeter, you always convert centimeter to meter by multiplying 10 to the power of minus 2. Those who have followed my lecture by now, they should be comfortable with this. Those who are not super comfortable, you have to use this. Okay, this is much easier than handling decimals. So 4 cancels, you get 9 into 10 to the power of 4 Newton per Coulomb. Okay, so this is the any one of the electric field EC and EA. And what about EB? EB, you can calculate EB as well. Formula is same, 1 by 4 pi epsilon naught Q by R dash square. Now what is R dash? R dash is 2 root 2. So again 9 into 10 to the power of 9 into 4 into 10 to the power of minus 9 divided by 2 root 2 into 10 to the power of minus 2 whole square. So you get 10 to the power of 10 to the power minus 9 cancels, 9 into 4, okay, divided by 4 into 2 into 10 to the power of minus 4. So 4 cancels, you get 4.5 into 10 to the power of 4. Okay, so these are the respective electric fields. Now this is not over. You cannot add electric fields like scalar. They are vector quantities. So what you have to do, you have to first add these two vectors. It is easy because they are perpendiculars. So EC and EA are perpendicular vector. So their resultant electric field ECA combined will be equals to, you take any one of the electric field and multiply it with root 2. Okay, you take any one of the electric field, you multiply with them with root 2. So if two vectors perpendicular to each other, if both of them are same, then their resultant is given by a root 2. Okay, you can use Pythagoras theorem, that is a square plus a square whole root, fine. Or you can use this is also fine. Some student confuse, sir, why it is so? So it will be a square plus a square, that is a into root 2. This is how you add two perpendicular vectors. Cos theta is 0. Okay. Now EA is given by 9 into 10 to the power of 4. So it will be 9 root 2 into 10 to the power of 4. and now ECA and EB are in same direction. ECA and EB both are in same direction. So this is the direction of ECA. This is also the direction of EB. So these two are in the same direction. When two vectors are in same direction, you can simply add them to find the net electric field. That is ECA plus EB. That is 9 root 2 10 to the power of 4 plus 4.5 into 10 to the power of 4, and if you calculate them you will get around let me see the answer. You will get 17.22 into 10 to the power of 4 Newton per Coulomb. Make sure you add the unit as well. Yes, correct, distortion. Radhika, what is your question? Guys, stop this. So would it be enough if we study 1 to 7 or 8 to cover all the theory based question and read other chapters for MCQ? Yes, of course, Owl. Okay, now let's move on to the next question. 2-point charges QA and so guys, those who are discussing in the chat right now, I cannot take all of them, all of them, but those who are listening to me carefully, remember that most of them are time waste students. Either they are from commerce team or they have already passed last year or they are studying in first PU. Okay, they are just using the chat to communicate amongst themselves. Ignore them, focus on the study, and if you have any real comments, comment it. I will always look for your comments and answer you. Okay, 2-point charges QA 5 microcoulomb and QB equals to minus 5 microcoulomb are located at A and B separated by 20 centimeter in vacuum. What is the electric field at the midpoint O of the line joining the charges? Okay, if a negative test charge of magnitude 2 nanocoulomb is placed at O, what is the force experienced by the test charge? I think this is a previous year question. Okay, here we have 5 microcoulomb and minus 5 microcoulomb separated by 20 centimeter. Okay, and what is the electric field at the midpoint O? What is the electric field at the midpoint O? So electric field at the midpoint O is given by E1 plus E2. What is E1? E1 is the electric field due to this charge, which is E1, and due to a positive charge electric field is away. Due to a negative charge electric field is towards. Okay, this is the negative charge, so E2 will be towards this minus 5, and E1 is due to positive charge, so it will be away from the positive charge. Okay, and so you can see that both of them are in the same direction. The distance is 20 centimeter, so this will be 10 centimeter, this will be also 10 centimeter, and obviously we can see that E1 is actually equals to E2. Okay, why? Magnitude wise charges are same, distances are also same, so let's say that is equals to E. So what is this E? E is obviously 1 by 4 pi epsilon naught charge divided by distance square, that is 9 into 10 to the power of 9 into Q. Here is 5 microcoulomb, 5 into 10 to the power of minus 6 divided by R square is 10 into 10 to the power of minus 2 whole square. It will be 45 into 10 to the power of 3 divided by 10 to the power of minus 2. So electric field will be 45 into 10 to the power of 5. Right, let me check 10 to the power value once. 3 minus 1 square minus 2, so it will be, yes, 45 into 10 to the power of 5. This is E. So the net electric field is E plus E. E plus E. Okay, both of them are E, so we are just adding it, so it will be equals to 2E. So it will be 2 into 45 into 10 to the power of 5, or it will be 9 into 10 to the power of 6 Newton per Coulomb. Do not forget to add the unit. Okay, do not forget to add the unit. Okay, next is so net electric field is done, so this is part A. Next is if a negative test charge of magnitude 2 nanocoulomb is placed, what is the force experienced by the test charge? So the force experienced by the test charge is Q into E. Okay, Q into E, and it is a negative test charge, so minus 2 nanocoulomb into 9 into 10 to the power of 6, that is minus 2 into 10 to the power of minus 9 into 9 into 10 to the power of 6, that is minus 18 into 10 to the power of minus 3 Newton. The negative sign indicates the force is along the opposite direction of the electric field. Okay, the negative sign indicates the force is in the opposite direction of the applied electric field. Okay, so 9 into 10 to the power of 6 Newton per Coulomb, 18 into 10 to the power of minus 3 Newton, okay, and negative sign indicates the force is along the opposite direction. What is the best way to revise MCQ, sir? I am good with the theory. I want to 115 in 15 MCQ. So what you can do, if you have a printed copy your question bank, open the question bank, practice all the MCQs and see if you are doing well or not. Okay, so you can take a break every hour, and also you can see that how much time you require to complete one chapter. Okay, so 30 MCQs, around 25 to 30 MCQs are there each chapter. Complete them before you go to bed. Your all MCQs will be answered. If you don't have time, if you want to study from lectures, then I have done a 200 MCQ from your model question paper. Watch it at 2x speed. That will also solve your queries, your doubts. Okay, these two things you can do. Is it necessary to use sign in force? Not necessary. Not necessary. Okay, because it is mentioned negative test charge, so you have to show that what is the meaning of this negative test charge. That's why I have used negative sign. If you are using sign, fine. If you are not using, then you have to mention that because it's a negative test charge, the force will act in the opposite direction of the electric field. Okay, basically this negative sign actually gives you an idea to write that line. Okay, what is the meaning of giving the negative or positive? If the positive is given, same force, negative is given, same force, but negative sign actually gives you the direction. The direction is, force is a vector quantity, so if you are using the sign, if you are mentioning it, it will be slightly better for the invigilator. That's it. Invigilator, sorry, examiner. Calculate the potential at point P due to a charge of 400 nanocoulomb located 9 centimeter away. Obtain the work done in moving the charge of 2 nanocoulomb from infinity to a point P. Does the answer depend on the path along which the charge is moved? Okay, let me complete quickly. So potential is given by 1 by 4 pi epsilon naught. Now you can write K as well. If you are using K, then don't forget to mention K is Coulomb constant. Okay, to avoid that I am using this. So potential at point P due to a charge of 400 nanocoulomb located 9 centimeter away. So here Q is 400 into 10 to the power of minus 9 Coulomb. Distance is 9 centimeter, that is 9 into 10 to the power of minus 2 meters. Okay, and 1 by 4 pi epsilon naught is 9 into 10 to the power of 9. Okay, charge is given 400 divided by distance is 9 into 10 to the power of minus 2. So 9 cancels, 10 to the power of 9, 10 to the power of minus 9 cancels. You get 400 into 10 to the power of 2, that is 4 into 10 to the power of 4 volt. So this is the potential. Okay, obtain the work done in moving a test charge of 2 nanocoulomb from infinity to the point. So work done to move a test charge is given by Q into V. Q is 2 nanocoulomb and V is 4 into 10 to the power of 4, that is 8 into 10 to the power of minus 5 joules. Now for work done, unit will be joules. Okay, does it depend on the path? Electric field is a conservative force field, so it is independent of path. Independent of path, or it does not depend on path. Okay, this line also is important. So if this question comes, a similar question comes, potential, calculate work done, and also explain any part that is mentioned in the question. Okay, so 4 into 10 to the power of 4 volt, 8 into 10 to the power of minus 5 joules, does not depend. Next, two charges 10 microcoulomb and 5 microcoulomb are 12 centimeter apart. Find the work done in bringing them 2 centimeter closer. Okay, this question is from your question bank. So here we have two charges 10 and 5, both are microcoulomb. Initial distance is 12 centimeter. So if you bring them by 2 centimeter closer, the final distance will be 10 centimeter. That's it. Okay, when you bring them closer by 2 centimeter, then the final distance will be 10 centimeter. How to solve it? You have to calculate the initial potential energy of the system. Initial potential energy is given by 1 by 4 pi epsilon naught Q1 Q2 upon R, not square, only R. This is not Coulomb's law, this is electric potential energy. Okay, electric potential energy of the system at the beginning. So this is UI and this is UF. Capital U is potential energy. Now let's put the values. 9 into 10 to the power of 9, and Q1 is 10 microcoulomb, 10 means 10 to the power of minus 6. Q2 is 5 microcoulomb, 5 into 10 to the power of minus 6, divided by distance R. R is 12 centimeter, 12 centimeter means 12 into 10 to the power of minus 2. Now simplify, 3, 4. Okay, so you get 3 5s are 15 by 4 into 10 to the power of 11 minus 12, 10 to the power of minus 1. Okay, so this is initial potential energy, that is 15 by 40. Okay, 3 5s are, so it will be 3 by 8 joules. This is the initial potential energy. You need to calculate the final potential energy. To calculate final potential energy, everything will be same except the distance will change. So final potential energy is K Q1 Q2 by new distance, okay, R dash or R1, okay, not square. So now it will be 9 into 10 to the power of 9 into 10 into 10 to the power of minus 6 into 5 into 10 to the power of minus 6 divided by 10 into 10 to the power of minus 2. So 10 cancels, you get 45 into 10 to the power of minus 1, that is 4.5. So it will be 4.5 joules. If I am not mistaken, 45 minus 12 minus plus 11 minus 4.5 joules. So the potential energy, change in potential energy is UF minus UI, and that will come out to be, I think I made some mistake here. Let me check. Yeah, I missed 110. I missed 110 over here. Yes, I missed 110 over here. Okay, so it will be not this, it will be simply 15 by 4. 15 by 4 means yes. 3.75. Okay, so potential difference in potential energy 4.5 minus 3.75, which will be 0.75. This is not 0.075, this will be 0.75 only. Okay, 0.75 joules. Unit is very, very important. Guys, now I will start putting you on timeout. Just give me a second. Okay. Now, next 45, a series LCR circuit contains a pure inductor of inductance 5 Henry, a capacitor of capacitance 20 microfarad and resistor of resistance 40 ohm. If the AC source of 200 volt 50 Hz is present in the circuit, find the impedance, also find the resonant frequency of the circuit. Okay, so inductance is given 5 Henry, capacitance is given 20 microfarad, resistance is given 40 ohm. Okay, 50 Hz. So initially the AC source is 200 volt and 50 Hz present in the circuit. Find the impedance. How to find the impedance? First step is to calculate XL. XL is 2 pi F into L. Okay, so 2 pi means 2 into 3.14, frequency is 50 and L is 5 Henry. Very simple. So you get 314 into 5, that is 1500, 50, 70. So 1570. Okay, so what I have done, you can use your calculator. You don't need to know how I have achieved here. Okay, use your calculator and calculate it. Okay, you will get 1570. What about XC? XC is 1 by 2 pi FC. So that will be 1 by 2 into 3.14 into F is 50 into 20 microfarad. 20 microfarad means 20 into 10 to the power of minus 6. Okay, so it will be 10 to the power of 6 divided by 2 into 3.14 into 50 into 20. Okay, now let's simplify with 10 to the power of powers. So here we get equals to 10 to the power of 6 divided by 2 into 3.14 into let me do one thing, let me multiply. 2 into 50 is 100, so 100, 3.14 into 100 into 20, so 1, 2, 3 zeros cancels, we get 1000 divided by 6.14. Okay, 1000 divided by 6.14, I think it will be approximately one something, 160 something. Yes, Pushpalal, if you are not if you are not discussing anything study related, I will put you on timeout again. Where all should we implement negative charge in all these chapters, sir? And times we multiply charge to potential to get work done, and why not here? Sometimes we multiply charge to potential to get work done. Why not? Which case you are saying? This is potential energy. Potential energy and work done are different. Aul, which question you are asking? Which case you are saying? Hello, Rajak. Question number 44. Okay. Sanjana, which question you want me to explain? Sanjana? This is potential energy. That's why we are not. You can calculate potential, and then you can do the work. But that will be a longer method. This is the easiest shortcut method. Because two charges are given, you can according to your method, you have to fix one charge, calculate potential, then multiply, find work done. That will take longer method. Okay, because it is isolated only two charges, potential energy is sufficient. You don't need to calculate potential here. Okay, you have to calculate potential at two different distances, then multiply and calculate the potential energy difference. Okay, that will be longer, much longer method. Okay, now Sanjana, which one you want to explain? So Sanjana, here we have two charges. Okay, two charges are there at a distance 12 centimeter. Now we are trying to bring two charges closer by 10 centimeter. We are trying to bring them closer by 2 centimeter. So what will be, guys, if you don't stop, I will put you time out again. Okay, those who are keep on discussing. Okay, let me block this. Okay, now so when you are bringing the charges by 2 centimeter closer, that means the final distance will be 10 centimeter. Okay, 12 minus 2 is 10. Now what? Now how to approach this problem? So first, initially these are the charges. Okay, these charges when they are separated by a distance 12 centimeter, they had a potential energy. How to calculate the potential energy? To calculate potential energy, we need 1 by 4 pi epsilon naught Q1 Q2 by R. Okay, 1 by 4 pi epsilon naught Q1 Q2 by R. This is the potential energy formula. Okay, two charges separated by a distance R, potential energy is 1 by 4 pi epsilon naught Q1 Q2 by R. Okay, so this is the initial potential energy. Initial potential energy means only difference is the distance will be 12. Okay, so you calculate the potential energy. When they are at the final position, the same, everything will be same, only the final distance will change to 10 centimeter. Okay, so now again we put the 10 centimeter, calculate the potential energy. Finally, final minus initial, that is the work done that you have to do. So this much work you have to do to bring them closer by 2 centimeter. Okay, now let's solve this question. What is XC, guys? If someone tell me. Ganesh Kumar, it is already uploaded in the PDF, in the drive. You can check on the older link, same link is same. Anyway, I will check it once more after this live is over. I cannot do that during my live, obviously, right? So I will check it once my live is over. 162.82. okay, 162.8. let me drop the 2. 162.2, that is the EMF. Now XC Whenever you are calculating XL or XC, always mention the unit. Now obviously what is impedance? Impedance is given by square root of R square plus XL minus XC whole square. So it will be square root of 40 whole square. Someone use your calculator, calculate this value and tell me the answer. 1570 minus 162.8 whole square. Okay, and whole root of this. I think it will be 1400 something. For numerical, can we refer? Yes, similar question will come, not exact question. XC I got 159. Maybe you have used in your calculator, maybe you have used the exact value of pi. Okay, you have divided by pi, but in your exam pi value is not allowed to use, so it's, start preparing with pi value for 3.14. If you use 3.14, one mistake I made also, sorry, it will be 6.28. Yes, 6.28. Maybe you are right, it may be 1.59. Okay, maybe 1.59. So let me, neither yours nor mine, so let me take it 160. Okay, let me take 160. Okay, done. 1411.33. 1411.3. Yes, I remember the answer. It will be 1411. That was almost correct. Yes, so this is the impedance. So if you do that, 3 marks is guaranteed. 3 marks will be there for calculating the impedance. Next part is also find the resonant frequency of the circuit. So resonant frequency is F0, which is given by 1 by 2 pi square root of LC. Okay, 1 by 2 pi 1 by 2 pi square root of LC. So that will give you the value of resonance frequency, 2 into 3.14 into 5 into 20 into 10 to the power of minus 6. Okay, so it will be 1 by 6.28 into 100 into 10 to the power of minus 6, that will be 10 to the power of minus 4 square root. So it will be 10 square by 6.28, that is 100 divided by 6.28. So it will be approximately 16 hertz. Okay, if this is 160, this will be 16, approximately 16 hertz. Should we mention the name of the TRS also in numerical? TRS means name of the TRS. Neeraj, 15.8, almost okay, almost okay. Okay, 16 hertz, 15.8, approximately 16 hertz. Terms, no, not necessarily required. What you should do, that you should write the given statement. Given L equals to 5 Henry, C equals to 20 microfarad, R equals to 50 hertz. Okay, while calculating the impedance, just write impedance. Impedance Z equals to, that is sufficient. You do not need to write the answer. Okay, at the end, if you get time, the impedance of the circuit is 1411 ohm and the resonance frequency is 16 hertz. Okay, if you write that, that will be sufficient. Otherwise, if you don't get time, suppose this is part A, this is part A answer, this is part B answer, that will also do. But if you get time, so show some politeness to the teacher. Okay, at the end write the answers in words. Okay, or at least answer Z equals to 1411 and F0 equals to 16 hertz. Okay, that is also okay. That is also okay. Okay, but you do not need to declare the variables, declare the terms. Okay, you just need to mention that what is all the given value, and if you can write inductive reactance, not necessary, but If you can do, you can do it. Inductive reactance, capacitive reactance. Okay, but not necessary. No one asks you. Everyone is obviously the formula you have to write. Then you substitute. Do not start writing from the second line. You know the formula, you are writing directly, that will not be accepted. Write the formula, then put the values, then calculate. Okay, so formula is very important. Writing the formula is very, very important. But even though you are not declaring the terms, but writing the formula is very, very important. A sinusoidal voltage, I think this is the last question of the day. A sinusoidal voltage of RMS value 200 volt and frequency 50 Hz is applied to a resistance to a series RC circuit, which R is 3 ohm, C is 800 microfarad. Calculate impedance, the current through the circuit, phase difference between current and the voltage. Okay, so first of all we have to calculate the impedance. To calculate impedance, obviously first thing is to calculate XC. No L is there, only XC is fine, so it will be 2 pi F into C. Okay, that is 1 by 2 into 3.14 into 50 into 800 into 10 to the power of minus 6, or 10 to the power of 6 divided by 2 into 50 is 100 into 3.14 into 800. 1, 2, 3, 4 zeros are there. So 4 zeros cancels, you get 2 over here. 10 square means 100. 100 divided by 3.14 into 8. So it will be approximately 100 divided by 25, that is 4 ohm. So inductive capacitive reactance is 4 ohm. So what is the impedance? Part A, impedance Z equals to square root of R square plus XC square. Okay, XL is not there, XL is 0, simply R square plus XC square. So in case you see RC or a RL based question, you should consider yourself lucky, you don't have to do one extra step. Okay, so now R square, R is 3 ohm and XC is 4 ohm, so it will be 5 ohm. So the impedance of the circuit is 5 ohm. The current through the circuit, so because they have not mentioned nothing, okay, current through the circuit means we are supposed to find the RMS current. Okay, RMS current, because if you see RMS value of the voltage is given, so RMS current is given by 200 divided by Z, that is 200 divided by 5, that is 40 ampere. Units are necessary, formula required is necessary, and declaring the variable is not necessary. Given values are, if you do it, it will be very good for the for teacher to know that you have copied the values correctly. Okay, second, phase difference between current and voltage. Phase difference between current and voltage is tan inverse XL minus XC by R, but here XL is 0, so it will be simply XC by R. No negative sign while calculating phase. Remember that while calculating phase, no negative sign. Okay, so it will be tan inverse XC is 4 and this is 3, so this will be approximately 53 degrees. Okay, this is the standard angle. 4 by 3, 3 by 4, 3 by 4 is 37 degrees and 4 by 3 is 53 degrees. You can check tangent table as well, but it is not required, it is 53 degrees. So tan inverse 4 by 3, it will be 53 degrees. And what is the phase? Current is leading, I is leading. You have to mention that in this case, I is leading the voltage by an angle 53 degrees. Okay, so because it's only capacitive circuit, no inductance is there, so current is leading. If XL is greater than XC, current is lagging. If XC is greater than XL, current is leading. No XL, that means current is leading. Okay, again Madhu, do not use negative sign. Do not use negative sign in phase. Okay, then if you are using negative sign, the meaning of this line will change. So always remember, you are taking a modulus over here. Do not take negative sign in the while you calculate the phase, because we are interpreting directly from XC and XL. Okay, so I is leading or lagging directly based on whether it's a C based circuit or L based circuit, like that. Okay, so here current is leading. So do not use a negative sign over here in while calculating phase. Phase should be always positive. Remember that phase should be always positive value. Based on the situation, it will be leading or lagging. Okay, that can be written in the words. If you write minus over here, someone might interpret that current is lagging, but actually negative is here. Negative lagging, that is positive. Okay, that's why I always recommend, do not use negative sign in the phase. Phase should be always clean positive. Okay, one Wheatstone network numerical. Neeraj, Wheatstone numerical based numerical I solved yesterday. I am not in a mood to solve one more Wheatstone bridge numerical. You can go check that out. But if you are seeing Wheatstone bridge related numerical, I will suggest you skip that. Okay, they can be tricky, and it will be unbalanced Wheatstone bridge numerical. Okay, obviously balanced Wheatstone bridge they will not give you, right? So they will give you unbalanced Wheatstone bridge. If it is normal circuit based, if you are very sure, if you have practiced enough, you can attempt it. But if it is a Wheatstone bridge circuit, I don't recommend it, because it will be 3 variables and 3 equations. So you need to solve 3 by 3 equation. Okay, 3 unknown, 3 equation, and that can be tricky and that can be lengthy as well. Okay, that's why I recommend that you should not solve it unless one of the values are given directly in the question. If one of the values is directly given in the question, then you can solve it. If it is not given, you should not attempt the question at all, because it will be very lengthy. At the end of it, during the pressure situation of the examination hall, you will make some mistake and your answer will be gone. So do not attempt numericals from Wheatstone bridge unless you have done at least a lot of practice from circuit theory based question, Wheatstone bridge question. Right now today doing it will be only giving you a headache. Okay, because it will process is longer. Answer will also be, you may not get a very desired answer. Okay, that's why I'm not doing any extra questions today. If you see that I have restricted myself electric charges, field, potential, and AC chapters. From there, these 3 chapters you are going to get 2 sure shot numerical. 1 numerical you should practice from ray optics, which are, in my opinion, is much easier. Electric current electricity you should not avoid, because for example, if the question is coming say a simple theory, simple formula based question, okay, or simple combination of cell based question, that are easy, those are easy, you should not ignore them. Okay, because but circuit theory based question, in my opinion, during the heat of exam you can make mistake and the questions will not be coming common, so you should not attempt that in the exam. Okay. Neeraj, last way to revise, first of all, make sure you sleep properly. 6 hours sleep before exam is very, very important. 6 hours, do not extend 8 hours, 6 hours sleep is important. Secondly, what you should do, first you should practice all the derivation once. Okay, at least if you are not writing it, fine, you have at least read the derivations, important derivations, read it once. Okay, diagrams you make sure, and one important part is keep yourself calm. Do not overexcite if you see questions are common, or do not depress yourself if you see few questions are uncommon. Okay, because if you read the question paper properly, even if you see some questions are not common, not there, you should be able to answer them if you keep yourself calm. Okay, keeping yourself calm is important. So first you focus on your derivations, that is very sure shot. Practice few numericals. I will recommend practice few numericals on your own from question bank or NCERT textbook, whatever is with you. Okay, question bank, if you have, practice few numericals. That is not that those questions are going to come, but it will give you a confidence that okay, these problems I am able to solve today. That means if some question is coming tomorrow, I will be able to solve them as well. So that is just for your confidence booster. Okay, the practicing does not mean that those question has to come in the exam. Okay, practice them so that your confidence level is well enough so that you are able to attempt those questions in the exam. Okay, because not practicing is not super good. Practicing more is very, very important. Okay, so these two things, and go through 2-3 marker questions as well once, 2-3 marker questions once, that will also sort them out. MCQs, if you get time, pick up few previous year papers, not the entire model paper. Take last 25, 24 papers. There are 3 papers. You can open your model paper. At the end of your model paper, previous year papers are given. Okay, if you don't have the papers, don't worry. At the end of the model paper, 24, 25 papers are given. Practice the numericals from there. 3 sets of 25, 3 sets of 24 are there. So you practice them. That will also give you some confidence as well. Okay, confidence is very important. Okay, if you are confident, for example, if you are following India's World Cup, if you are confident, you can hit sixes and you can win the match. If you are not confident, even if you the ball is full toss, you will get out, right? So remember that. With this, I would like to end this lecture. Tomorrow morning I will see you in the live. Okay, and all the best. Is it better to watch MCQ video now? Neeraj, you can watch it at 2x speed. By a 5-hour video, so it will be over by 2.5 hours. So if you watch it in 2x speed, definitely you can watch. Okay, but not at a, sir, cos phi equals to r by z formula. Cos phi is the power factor. Cos phi is equal to r by z, formula derivation will not come. Cos phi is called power factor. Power factor is cos phi, which is given by r by z. Okay. In case exam, what they will ask, that phase difference and then power factor. Phase difference is tan inverse xl minus xc by r. Okay, from there you can calculate the cos phi for power factor. And Neeraj, one more thing you can do is you can download the PDF and have a look at the PDF itself. Okay, that will also be beneficial. If you want to watch the video, watch it at 2x speed. If you don't want to watch the video, download the PDF. PDF is there in our Google Drive folder link. You can download it from there, and obviously you can have a look at that. Okay. So with this note, I don't want to disturb too much time of you. You should seriously go and self-study. Okay, no more videos till tomorrow morning. Now you go and do some self-study. In between, if you require some help, you can watch some of the videos. Okay, but do not watch complete videos. Do take some time and self-study for at least 4-5 hours till now. Okay, till your 11 and 12, go do self-study. Wake up in the morning. Be live with me at 6 to 7. Freshen up, go to college, appear your paper, it will be best. Okay, that is assurance from my side. If you are following all the lectures, definitely you will be going to give the best exam in your life. Even if you have joined recently also, you will also don't need to worry too much. Okay, and those who are watching, sir, I want to pass, passing package is out. Don't forget to check the passing package as well. See you tomorrow morning. Till then, bye.